Hi Algebra, in lesson 4 here we're going to be working on using function rules along with our functions. So it's going to be a lot of plugging things in and evaluating functions. Here we go. In our first function f of x, we notice that if we plug 1 in for x, so f of 1 coming from right here, we get 10 minus 2 times 1, which if I evaluate that out, I would end up with 8. When I check all the rest of our inputs for x and I plug them in, I see that these outputs are what we get when we evaluate the function when we plug in our number for x. In our function g of x, it works the same way. If I have an x value here of -2, that's our input. So g of -2 equals -2. I'm plugging that in for x cubed. So that means -2 times -2 times -2. That would get us -8. The same thing applies all the way down this table. We're using our x value as our input, plugging that in for x, and evaluating the function. Here we have functions f, g, h, and k, and each function is doing something different with our input x. And so we're going to match each function with which description in words it goes with. Function f matches with description c because we're saying to get the output, we're going to multiply the input, that's our x, by 3 and then subtract 7 from the result. In function g, we see that the order of these operations matter. So for example, in g, we're going to subtract 7 from x first. So that means subtract 7 from the input, then multiply the result by 3. And here's the other two. In h, we're going to divide the input by 3 first and then subtract 7. And in k, we're going to subtract 7 first and then divide that result by 3. Number 2 is asking us when the input is 6, the output is -3, which function is that true for? So I'm starting with function f, and I'm plugging in 6 for x, that's my input, and so my function looks like this, and I'm going to finish evaluating that. 3 times 6 is 18, minus 7 is going to be 11. So I know it's not function f, so which one is it, g, h, or k? It is function g. When I plug in 6 for x, my function ends up looking like this. I get 3 times -1, which is -3. So when the input is 6, the output is -3. Now we're going to start creating our own rules for a function. For this first one, we have a square. So I drew a square. It has a side length of 9. So that means that it's an area of 81 because 9 times 9 is going to be 81. So we're going to complete this table here. Given different side lengths for a square, what would the area be? So here's our areas given the different side lengths. Remember, it's going to be that side length times itself, which leads us to the last one. If we have a side length of s, that means any side length at all, we're going to find the area by taking s times s, or s squared. We also want to write this in function notation. They're telling us to name the function a, and so we're going to say a of, the side length is s, so a of s equals s squared. This is saying that the area of a square with side length s is going to equal s squared. What does a of 2 represent in this situation? So I'm using my function to plug it in. A of 2 is going to be the same as 2 squared, which is 4. And that means that the area of a square with a side length of 2 is 4. Now we're going to graph all of the data that we have on our coordinate plane right here. We know the data from this table, so let's graph that and see what we end up with. Here's what our graph ends up looking like. I did add the point 0, 0 because I know if a square has side length of 0, its area is going to be 0. I added in my other data and we start to see this curve here. I did connect it with a line because we can have all those partial values in between, all the fractions and decimals. Now we have an example with perimeter. We have a roll of paper that is 3 feet wide and we're going to roll it out and cut it to any length. If we cut it to a length of 2.5 feet, I'm going to label that right there. What is the perimeter of the paper? Well, we could figure that out by doing 2.5 plus 2.5 plus 3 plus 3, and that's going to be the same as 11 as my perimeter. Here's what we end up with our different perimeters, and then down here, if we have a length of L, I'm going to draw a new one right here. Here's my sheet of paper, 3 feet wide on 2 sides, and then a length of L right here. And I know that for perimeter, I'm going to add everything up. And so that's going to be L plus L, or 2L, plus 3, which I can simplify to 6. So there's my general rule for my function. Writing our rule for the function right here, we're going to name it P, and it's going to give the perimeter of the paper when the side length in feet is L. And so I'm going to refer back to that rule we just created right here. And we are going to make this function p of L equals 2L plus 6. P of 11 means that I'm going to be plugging 11 in for the length of the paper. And when I evaluate that, I get P of 11 equals 28. And that means a paper 11 feet long has a perimeter of 28 feet. Now we're going to create a graph using the data we have right here. This time we cannot say that the 0.00 is going to be on there because we already know that these have a length of 3. This time we see that the graph is a straight line, and I did connect the points because we could have decimals and fractions in between. And we notice that it does not go through the origin. We have a y-intercept here of about 6, which makes sense if we think of slope-intercept form.